Cartesian coordinates and polar coordinates. Cartesian coordinates of a point P, x, y are obtained like this from the origin. X units you go along the x-axis and y units go along the y-axis, parallel to the y-axis, y unit. That means basically these two numbers x and y are the distance of the point to the y-axis. This is the x coordinate, and the distance of the point to the x-axis. This is the y coordinate. So we use these two distances, distance to the x-axis and distance to the y-axis. They are the coordinates. Now we will introduce another system to express the position of a point. Position of the same point P. We can express in a different way also. That goes this way. The position of the point can be expressed in terms of the direct distance to the point from the origin. How far is it from the origin, called r? And also, not only the direct distance, at what standard position angle is that direct distance measured? Standard position angle theta measured on the direct distance theta. So the position of this point going to be written in terms of this r and theta. These are the parameters, the numbers on which, the measures on which this position will depend, the coordinates will depend. Whereas in Cartesian system, it depends on the distance to the y-axis and the distance to the x-axis. Now how to get this new one? Of course, with the help of the original one, the one which we are familiar with, the Cartesian coordinates. Let's compare these two. In fact, I was talking about the same point. The point is the same. This P, x, y, if I shift this OP here, this right triangle is now formed here. In this right triangle, that angle theta is now here. This direct distance r, this is the hypotenuse. So from this right triangle, let us write the trigonometric ratios that we are familiar with. Cos theta is adjacent side by hypotenuse. So it is x by r. From here we can say x is equal to r cos theta by cross multiplying. X is r cos theta, x coordinate will be r cos theta. Also, sin theta is equal to y by r. By cross multiplying, we can say y is equal to r sin theta. So instead of this x and y coordinates, we may write in place of x r cos theta, in place of y r sin theta. So this point can be rewritten as r cos theta, r sin theta. That means we eliminated the x and y from here. Instead of the direct distances x and y, we have written the coordinates in terms of r and theta. If we write a coordinates in terms of r and theta, that is called polar coordinates. When the point is written in terms of that x and y, that is called Cartesian coordinates. Polar coordinates and Cartesian coordinates. Let's look at some examples. Here, this angle is 30 degree and say this point is say 2 units away. So the coordinates of this P will be 2 cos 30, 2 sin 30. R is 2, theta is 30 degree. 2 cos 30 degree, 2 sin 30 degree. And as we know, cos 30 value is root 3 by 2, sin 30's value is 1 by 2. By putting them, we get the coordinates. We did not measure this x and y. Without that, we are able to write the coordinates of a point. See another point on this terminal side. Having the angle same, but the distance I am taking 4 now. So the coordinates of this point Q will be 4 cos 30 is 4 sin 30, according to the polar coordinates. One more point let me take, which is at a distance 7 units away from the origin. R is 7. And look, angle standard position is the same. So the coordinates will be 7 cos 30, 7 sin 30. Similar, if we go for another angle, say I am taking the angle 45 degree. So if you have a point 2 units away having 45 degree drawn on the standard position, the point's coordinates will be 2 cos 45 degree, 2 sin 45 degree. And then we will give the value of 45 degree. Cos 45 degree is 1 by root 2. Sin 45 degree is 1 by root 2. So 2 into 1 by root 2, 2 into 1 by root 2 will be the coordinates. Same again, another point, say at 4 units away, that is 4 cos 45, 4 sin 45, etc. Having another distance 7 or any other distance also would do. Here it is 7 cos 45 degree, 7 sin 45 degree.